Hi, it's Chris, and we are currently taking a look at questions 16 through 18 in the grid-in section of Section 3, SAT Practice Test 3. So for question 16, here they want to know one possible solution to the equation above. Now it says x is greater than 0, and that's a given whenever you're dealing with the grid-ins because you can't grid in a negative number. So if you do see that in a question, it usually just means that you might end up with more than one solution, but not to worry. You'll be able to figure out which one you're supposed to input right when you go to actually bubble it in, because even if you tried to input, let's say, a -2, you'd be searching around and you wouldn't see a negative anywhere, and that would clue you into, oh, let me just put one of these other solutions. So sometimes that information can be a bit redundant, but that's why they have that information there. But for this, to figure out a possible solution, let's try to simplify this. We want to go ahead and distribute, and then we want to bring everything to the same side. So when we distribute, we'll get x to the 5th minus 5x cubed. And then if we bring over the negative 4x, that would be plus 4x equals 0. And then here they all have an x in common, so we could factor out an x, and we'd be left with x to the 4th minus 5x squared plus 4 equals 0. So one possible solution could have been x equals 0, because remember, you can set each factor equal to 0, but it does say that x has to be greater than 0, so we can't use that one either. All right, so let's see if we could factor this out a little bit further. Here we would have x squared minus 4 and x squared minus 1 when we go to factor out that trinomial. And then here we can factor even further. X squared minus 4, that's a difference of squares, which we should memorize. The factoring for, which would be x plus 2x minus 2. And x squared minus 1 is also a difference of squares, which would give us x plus 1, x minus 1. Now when we set each of these equal to 0, then our results would be x equals 0, and then x could equal a -2, x could equal a +2, x could equal a -1, x could equal a +1. And because they give us this stipulation, it lets us know that the only two possible values that we could put in are 2 and 1 for that. Now if you're glancing at this, you might think, whoa, that looks pretty challenging for question 16. I thought that these grid-ins were supposed to go easy to hard, and they do. So let's put that over there a little bit smaller for the moment, and let's see what else we could try if we got to a question like this and maybe felt a little bit stuck. Because I'll admit, some of that factoring is not the easiest in the world. So what we can try, if we think the question's supposed to be easy based on where it is, remember, your grid-ins are going to reset in terms of difficulty level. They're going to go easy to hard. So question 16 should be a little bit easier. And if you're on an easy question, then a great tip is to try easy values. And you'll be surprised, even if you don't know how to solve algebraically, how often the numerical values that you test out will work perfectly the way you were hoping they would. So in this case, if I was stuck on the factoring, I said, well, let me just try easy values. They tell me x has to be greater than 0. So why don't I just try the next value that I think of that's greater than 0? And again, we want easy values because it's supposed to be an easy question. So I'm not going to try 0.739 or something that is a messy decimal. Next value that I think of greater than 0 that I might test out would be 1. Let's try it and see if that works. So here I'd have 1 cubed, which is just 1, and then 1 squared minus 5 equals -4 times 1. Let's see if that works. That would be 1 times -4, which would be -4 on the left, equals -4. Oh my gosh, let's look at that. 1 did work. So I could just test out some easy values and see if they work. And if 1 didn't work, guess what? As we already saw from the complex factoring we did, we see that 2 is another possible value. But keep that in mind. If you have an easy question and you're stuck, try easy values, and you'll be surprised how often that works. Let's take a look at number 17. And here they just want to know the value of x. So let's see if we can combine like terms. 7 over 9x minus 4 over 9x. That's going to give us 3 over 9x. And then equals, here I would want to try to get a common denominator. And the least common denominator is going to be 12 on that right side. So between 4 and 12, I can multiply this first fraction. I can multiply the top and the bottom times 3. And that would give me 3 over 12. So 1/4 is equivalent to 3/12. And then we can add those fractions together. Now on the left side, 3 over 9 can actually be reduced. They're both divisible by 3, so we're really left with 1/3 x equals 3 over 12 plus 5 over 12 would be 8 over 12. And that we could also reduce on that right side. So anytime we can reduce, let's go ahead and take advantage of that. 4 goes into each of those. So that would give us 1/3 x equals 2/3. And to multiply by that reciprocal and be left with just x by itself, multiply both sides by 3. And it cancels out those 3's and those denominators. We're just left with x equals 2 on that question. So surprisingly enough, a similar strategy could potentially work here. Even though this equation looks like it's going to be challenging with all those fractions, if you weren't sure of what to do, try some simple values, but it is really helpful to make sure we're comfortable enough with fractions to combine like terms, add and subtract, find common denominators effectively, because that's a necessary skill that we'll need for test day. Up next, let's take a look at question 18. And here we have a figure, and they tell us two isosceles triangles are shown above. If 180 minus z equals 2y and y equals 75, what is the value for x? So again, they really just want the value for x, but they give us some values that we can at least plug into the information given and start to piece this together. We know that y is 75 because they tell us that value right in the question. They say y is 75. And then they give us an equation where we could solve for z if we know a numerical value for y. Let's see what we get. So 180 minus z equals 2 times 75. 180 minus z equals 2 times 75, which is 150. And if we rearrange and solve, we could subtract 180 from both sides. Negative z equals negative 30. Divide by a negative 1 or cancel those negatives out, and we're left with z equals 30. But that's not our answer, because remember, they're asking for x. But hopefully that can help us get a little bit closer. Let's add that into our figure. So if z is 30, we're still trying to find x. Now they told us that these triangles were isosceles, which means that these two sides are equal, and there is a qualitative relationship between the sides of a triangle and the angles opposite those sides. So if these two sides are the same, that means that the angles across from those sides, that would be this angle and that angle over there, so those two corner angles, those angles would also have to be equal. We don't know what they are, but we know that they equal each other. So let's see if we could figure out what they would be. And to do that, we just have to know the sum of the angles for a triangle. So if you add them all up for a triangle, what is that supposed to sum to? Hopefully we're thinking of the magic number 180 in our head, which is absolutely correct. So we would have here 180 for all three of those together. And for now, we can call these other angles. Let's make up another variable that's not already in the question. We have x, y, and z, so maybe we'll call these a for angle. But we know they're both the same. So as an equation, we would say that z plus a or plus 2a has to equal 180. And we know z is 30. So this is like saying that 30-degree angle that we have here plus those other two equals 180. Subtract 30. 2a would be 150. Divide by 2. A would equal 75. So each of these angles would be 75 degrees. And to find x, any idea what the sum of angles along a straight line has to be. So again, this is one of those where we have to know a few properties of angles outside of the information given directly in the question. And here the sum of those angles also has to be 180, because if you look at it, think of it like a picture, right? Along one side of that straight line is really just half of a circle, and that's 180 degrees. So here we have that 75-degree angle plus the x that we're solving for equals 180. Subtract 75, x equals 105, and that's our answer there. So this question requires a little bit of outside knowledge, but they do also give us a lot of additional information in the question itself, and hopefully we can piece it all together correctly to get 105 for x. Up next, we'll finish out this section by looking